Today we're going to talk about ratios and proportions. So we're going to start out with the ratio. A ratio is just the comparison of two numbers. So if we are looking at these pictures and we asked, what's the ratio of the side lengths? Well, if you go this way, it's 3:1. And we can write that as 3:1. We can put it as 3/1. If it goes the other way, it would be different. It would be 1/3 or 1:3, depending on which direction you go. So we've seen ratios before. Here's an example of one of those ratio problems we might have had in the past. In a triangle, the ratio of the measures of the sides is 8:7:5. Its perimeter is 240. Find the length of each side. So we know when we have these ratios, we typically just put an X on each one. And since it's the perimeter of a triangle, we add them up to equal 240. So now I'm going to grab my calculator and find out 8 plus 7 plus 5 is 20. So 20x equals 240. And when I divide by 20, I get x is 12. So then I go back to each side and I say, well, 8 times 12 is 96. 7 times 12 is 84. And 5 times 12 is 60. So they have this ratio of 8:7:5, and together they add up to 240. Next, we have proportions. You've seen proportions before. A proportion is just the equality of two ratios. So two ratios set equal to each other. And we have something called the cross products property. You might have heard it called cross multiplying or maybe some other things. But basically, if I multiply right here, 3 times 32, it will equal the other cross, which is 8 times x. So I grab my calculator. 3 times 32 is 96. And 96 divided by 8, x is 12. Now I realize for some of you, you look at that one and you're like, well, I could have just said 8 times 4 is 32 and 3 times 4 is 12. I could have scaled that. And it is true. You could do that for this problem. Sometimes you can use the scale. You can go, oh, 8 goes into 32 times 4 and then 3 times 4. But then you get to a problem like this one that has x's in it, and you can't do that same scaling thing. So this is how we're going to do this one. We have to cross multiply. 1 times 6x is 6x. And then when I multiply 4 times x plus 1, make sure to use the distributive property. And we get 6x equals 4x plus 4. And we solve it like normal. Subtract 4x and then divide by 2. So x is 2. And I can go back and check that. If I go 1 over, let's see, 2 plus 1 is 3. Does it really equal 4 over 6 times 2 is 12? It does. 1/3 really does equal 4/12. So that's cross multiplying, or the cross products property. Now, real quick, let's talk about our similar polygons. Similar polygons, and we'll discuss this more in a future lesson, but similar polygons have congruent angles and proportional sides. So notice in this trapezoid, when the little trapezoid got bigger, the angles stayed the same, but the side lengths became different. So let's make up some numbers. Let's say this one's 3 and this one's 9. And we'll make this, well, this one can be 3 also. They look close to the same. Let's make this one 5. Now, if my proportion has to be the same, I can figure out this missing side. So let's talk about the scale factor. When you find the scale factor of your shapes, of your similar shapes, you always go new over old. We call that image to pre-image. So in this picture, if I was going from left to right, I said, what is the scale factor that gets me from the little picture to the big picture? Well, I would just do 9 divided by 3. The scale factor of this one would be 3. So that means everything in this little picture times 3 is going to equal the new side. So 5 times 3 would be 15. And I still have that same proportion of 3 times 3 is 9, 5 times 3 is 15. This one might be 4, and 4 times 3 would be 12. So they are all in that same proportion, that ratio of 3 to 1. All right, here's an important question. It's kind of a weird one, but it says find the ratio of x to y. So we've got this expression here, and we're going to try to work it out so we get x over y equals some number over here. So we're going to use our cross products again. We're going to multiply 3 times x plus 2y. Remember, we're going to distribute. And then this direction, we're going to multiply 5 times x plus y. So let's do the distributive property and see what we've got left. I've got 3x plus 6y equals 5x plus 5y. Now here's my tip. I want to get just x over y. So the first thing you want to do here is get all the x's to one side and all the y's to the other. It doesn't matter which. So if I subtract 3x from both sides, and then I'm going to do a subtract 5y from both sides, I get this. Y equals 2x. Now I want it to say x over y. So I'm going to divide both sides by y. Well, then I don't want any numbers in front of x, so I'm also going to divide by 2. So look what happens. Those y's cancel. Oop, that leaves me a 1 on the top. These 2's divide out, which leaves me x over y. So x over y equals 1/2. So that seems kind of weird. You start solving it, you get all the x's on one side and the y's on the other. Then you're going to divide by y. And whatever number was in front of x, you're going to divide by that one to get your ratio of x to y. All right, if the area of a rectangle is 2,028 square meters, the ratio of the length to the width is 34. Find the length, or 3 to 4. All right, so we did one earlier that was a perimeter question. This one's an area question. So if my ratio is 3 to 4, I'm just going to go ahead and call one of them 3x and the other one 4x. That says the length to the width. So this one's the length and this one's the width because they go in order. Now, how do I find the area of a rectangle? I do length times width. So be careful here. 3x times 4x is 12x squared. Be careful there. Equals 2,028 square meters. So if I want to know what x is, I take my 2,028, divide by 12. Oh, looky there. I get 169, which happens to be a perfect square. If you don't believe me, type it in. The square root of 169 is 13. So x is 13, which means the width was 4 times 13. That's 52. And the length is 3 times 13, which was 39. I'm going to double check just because I like to check these things. Does 52 times 39 really equal 2028? Yes, it does. So we are good. All right, the last thing in this lesson is called fractional distance. I'm going to give you 2 points, and I'm going to ask you to find a point that's a fraction of the distance between them. So we're not just doing the distance formula, we're finding part of the distance, which is actually easier. So let's start out with this one. M is -4, 7. So we've got to find that point right here. That's M. And N is 6, -8. Okay, so here's my segment. I want to find a point that's 3/5 of the distance from M to P. So here's what we do. We're going to measure the distance in 2 parts. We're going to measure the distance straight down from M to N, and then over. And then we're going to take 3/5 of each of those. So if I start up here and work my way down to N, how far is it from, where am I here? 7 down to -8. So if you counted those, you would get 15. Or if you, like me, I just go, well, from here to here's 7, from here to here's 8, combine that to get 15 altogether. And now how far is it across? Well, I was at -4, and I went all the way over to 6. So that should be 10. Well, I want 3/5 of the distance from M to P. Well, what's 3/5 of 15? You can do that in your head. 15 divided by 5 is 3. 3 times 3 is 9. The denominator is dividing. That always helps me. 3/5 times 10. 10 divided by 5 is 2. 2 times 3 is 6. So 3/5 of the distance would be down 9 over 6. You can count that on your graph, or you could start at M. Notice they told us to go from M to P. So if I go down 9, that's from the 7. 7 minus 9 is -2. If I go to the right 6, that's plus 6 from the -4, and I should end up at 2, -2. Looky there, it's a point on my line. So you can either take your 3/5 and count it to get to your new point, or you could start at that original point and either add or subtract depending on your direction. Going down 9, we're going to subtract from our y value. Going to the right 6, we're going to add to our x value. So that's all there is to this fractional distance. I'm not sure, but there might be one more practice problem. And there is. Find the coordinates of the point that is 1/4 of the distance from C to A. All right, so this time we're going from C to A, so be careful you get your direction correct. A is at 5, -2. And C is at -7, 6. It is hard to see those lines. We'll make do. So remember, we're going to do this in components, and it doesn't matter if you go over and down or up and over or which way you go. Just make yourself a triangle. And if you have a really good graph, you can count the spaces easily. If it's hard to see the points, you may just want to use your coordinates. So if I started at C and went over to A, how did I get from -7 over to +5? How far did I count? Well, hopefully you can tell that from -7 to +5, I went to the right 12 spaces. This is 7 plus 5 is 12. And then how did I get from 6 to -2? So here I am at +6, and I want to go down to -2. So that was 8 spaces. I went down 8 spaces because remember, from C to A, it makes a big deal which direction we go. Now we just do 1/4. 1/4 of 12 is 3. 1/4 of 8 is 2. So for my new point, I start at C, and I'm going to go to the right 3, which is a +3, and I'm going to go down 2, which is a -2. So that should put me at 4, 4. Haha, -7 plus 3 is -4. Now that'll work. -4, 4. This is 1/4 of the total distance from C to A.